Hello students, this is Mr. Ezra. Today we're going to talk about one of the most famous formulas in the world, the quadratic formula. And you might remember in a previous video we talked about how to derive the quadratic formula by completing the square. Today we are just going to use the formula, look at some practice questions, and make sure that we are feeling good about how to use this formula to solve many different types of quadratic equations. The basic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Please remember that the a, b, and c are the number parts of the quadratic formula. If there is a part missing, like there's no x part, it's just like something x squared plus something, you can use a 0 for that missing part. And if there is an x squared or an x in the formula without a number in front of it, you just use a 1, and we might see some examples of that. Now, this is one of those formulas that students are just expected to memorize. You got to know it, and you can just straight up memorize it. It's really not that bad to memorize. A lot of students remember it with a song. That's how I was taught to memorize it when I was in high school. It went to the tune, nursery rhyme tune. It was like this. Negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. And that worked for me. I remember kind of humming it to myself when I was taking tests to make sure that I had all the letters in the right place. Another way that I've seen, I believe that this was from the website Yay Math, Y-A-Y Math. The teacher on that website, he makes videos, and he told a story, and I remember the story still because it describes the quadratic formula. It was a story of a negative boy who was trying to decide if he should or should not go to the radical party, but the boy was square and he decided not to go, and he missed out on 4 awesome chicks. But, it wasn't too bad because the party was all over by 2 a.m. anyway. So using the letters A, B, and C, the story or the song might help you to memorize the order of things in the quadratic formula. You got to know it. You need to memorize it. I'm not going to give it to you on the next quiz or test or anything. It's just one of those things that as you practice it, write it down every time, and eventually you will learn it. Our first question today is to use the quadratic formula to find the zeros. I first need to make sure that I say that when we're using the quadratic formula, the terms need to be in order from greatest degree to lowest degree. So it should always have the squared part first, and then the x part, and then the constant part second. Those terms should be in that order. We'll identify a, b, and c. So a here is going to be 1. There's an invisible 1 in front of the x squared. B is going to be negative 6. And c is going to be 3. From here, we take those numbers, and in the formula, which I've got over here on the left, we're going to plug in those numbers for the letters, making sure that all the signs and symbols are exactly the way they're in the formula, but any number that I have over here, I plug it in. So I start with negative b. Well, that's negative, and then I'm plugging in a negative 6. So remember to put that negative 6 in parentheses so that you can see it's minus a negative or negative 6. Plus or minus the square root of b squared. I'm again put this in parentheses so your calculator calculates it correctly if you use your calculator. Minus 4 times 1 times 3. And all of this is over by 2 times 1. The first thing I like to do is to find the discriminant. You remember the discriminant from the last video. That's the part underneath the radical. I'm not going to actually use the square root yet. I'm just going to put all of this in my calculator or do it all in my head or do it a bit of it at a time, but get this figured out. And then I'm going to clean up the left side and the bottom side as well. So negative 6 is positive 6 plus or minus. I know I'm going to have a square root. Then I've got to do negative 6 squared, which is positive 36, minus 4 times 1 times 3. And that is going to be 24. All over by 2 times 1 or 2. Now at this point some students are going to want to try to reduce, but we really can't reduce anything until we take care of this radical here. So go back and review how to deal with square roots, how to reduce them. We cannot use the decimal form. It needs to stay as a square root for this question. So is there a perfect square that goes into 24? Well, 24 is divisible by 4. 4 goes into it 6 times. 4 times 6 is 24. 4 is a perfect square, so I can take the square root of 4 and move that square root out to the front of the quadratic. So I'm going to have 6 plus or minus, and the square root of 4 is 2, and that 6 is going to be left underneath the radical because it's not a perfect square and no perfect square goes into it, and all of this is divisible by 2. Now remember, I like for you to, at this point, kind of split this up to 2 fractions. You got the 6 over 2, and you've got the 2 root 6 over 2. 6 over 2 reduces to be 3. 6 divided by 2 is 3. And the 2 divided by 2 cancels out. So we have plus or minus. These cancel out, leaving us with just 1 behind, but we don't have to write the 1 in front of a radical. It's just going to be root 6. 3 plus or minus root 6. Now remember, you can't touch something under a radical with something that's not under a radical. So I can't reduce this 2 with the 6 because the 2 is not a root and the 6 is a square root. And square roots only reduce with other square roots. So the only things that could reduce here was this 2 and this 2. And I have to leave the square root behind. Now, I'm going to circle this answer. It's a good answer, but remember it's actually 2 answers. It's 3 plus root 6 and 3 minus root 6. Question number 2, we've got x squared plus 9x plus 10. It is in descending order already, so I can identify my A and B and C. And then I'm going to plug those into the formula. So x is going to be negative b, which is negative 9, plus or minus the square root. It's going to be 9 squared. B squared is 9 squared here. Minus 4 times a, which is 1, times c, which is 10. All over by 2 times a, which is 2 times 1. So when I clean this up, I've got negative 9 at the beginning. I've got 2 on the bottom, and I want to find the discriminant. 9 squared, which is 81, minus 4 times 1 times 10. And when you do all of that together, you get 41. Now, 41, I believe, is not a perfect, well, it is not a perfect square, and I don't think there's a perfect square that goes into it, because I think of perfect squares less than 41, like 4, which doesn't go into it, and 9 doesn't go into it, and 16 doesn't go into it, and 25 doesn't go into it. So 2 squared, 3 squared, 4 squared, and 5 squared don't, and we're almost too big at this point. 36 isn't going to go into it, and 49 is too big. So since no perfect squares divide into it, we can stop here. 9 and 2 don't reduce. Some students will circle this, and it is an acceptable answer. So I'm going to go ahead and circle it here. Or you will often see it broken up into 2 fractions as negative 9 over 2 plus or minus root 41 over 2. And neither of those fractions can be reduced. The other way that you might see this is as 2 separate answers, where you've got the plus version and then the minus version, because really this is negative 9 plus root 41 over 2 as one solution, and negative 9 minus root 41 over 2 as the second solution. Question number 3 is not in descending order, is it? So we are going to have to reorder things here. The 2x squared is good. That can go first. But the next part needs to be this x. And how do I get an x across an equal sign? Well, I'm going to have to use an opposite operation. So since it's a positive 5x, I'm going to subtract it over to the left side, which will give me an x on the left. So since it was positive over here, I subtracted over. I'm going to have minus 5x and then plus 4. And I want this in descending order, so I'm putting the plus 4 at the end, the constant at the end. And that's all going to be equal to 0 now, which is what we want when we're solving a quadratic. Everything should be on one side, 0 should be on the other side. Now we're going to use the formula, which is over here. We've got x is going to be equal to negative b, which is the opposite of negative 5, plus or minus the square root of b squared, which is negative 5 squared, minus 4 times a times c, plugging in those numbers and not the letters, all over by 2 times a. In this case, that a is going to be a 2. All right, so as we clean this up, the opposite of negative 5 is positive 5, plus or minus. All of it's going to be over both the left side and the right side of the plus or minus are over 2 times 2, which is 4. And I need to find the discriminant, which is negative 5 squared, positive 25, minus 4 times 2 times 4. And I just like to put this all in my calculator at one time. I can usually do it in my head if I really want to, but if I have a calculator handy, I might just kind of throw it in the calculator. I get negative 7. So 25 minus 4 times 2 times 4 is negative 7. Now, when I look at this negative 7, I see there's a negative under the radical. We can never have negatives under the radical. So we have to think of this as the square root of negative 1 times the square root of 7. Because what is the square root of negative 1? We use the letter I. It's an imaginary number. We want to get that imaginary number out from under the radical. 7 is not a perfect square, and no perfect square divides into it, so it's actually going to stay under the radical. So we can represent this answer as 5 plus or minus I times root 7 all over by 4. So 5 plus or minus I root 7 over 4 is an acceptable answer. Remember that you can also split it apart as two fractions, so 5/4 plus or minus I root 7 over 4, where both parts are over 4. And I'm making sure that I say this for a few ways. If this is an open response question and you leave it as this, or you leave it as this, or you break it into two answers with the plus and then the minus, that's all of those are correct. On a multiple choice question, which is especially in Moodle you will see, you are going to want to make sure that you know the different representations because the answer key could have it either way. The multiple choice options could be either way. Notice I'm not reducing 5 over 4 because I can't, and I and 4 don't reduce, and radicals and non-radicals don't reduce. So this is the best answer that I can get for this question. Number 4, is it in descending order? It kind of looks like it is because we got our squared part and our x part and our constant part, but the constant part is on the wrong side of the equal sign. So we're going to have to get it across the equal sign by subtracting 1 on both sides. Which would give us 2x squared minus 4x minus 1 equals 0. And now that everything's on the left side of the equal sign, I can identify A, B, and C. A is going to be 2, B is going to be negative 4, C is going to be negative 1, and I'm going to start using the quadratic formula. Okay, so x is going to be equal to the opposite of b, which is, in this case, the opposite of negative 4, plus or minus the square root of b squared. Whenever you square this part, it's always going to end up being positive, just that squared part. So the negative is there, but when I square negative 4, I get positive 16. So just be aware, sometimes students forget that and they end up getting the wrong answer. And the only thing they've done is they didn't square this negative correctly. So b squared minus 4, always a 4 there, times a, which is 2, times c, which is negative 1. The signs are important as you're kind of pulling them over. So this negative 1 is going to behave differently than a positive 1 would behave when I'm finding the discriminant. And 2 times 2 on the bottom. All right. So as I work through this, the opposite of negative 4 is positive 4, plus or minus. I know I've got a 2 times 2 on the bottom, and I have to find the discriminant. I haven't really focused on it in this video, but remember the discriminant tells you something. If it's positive, you have 2 real solutions. If it's negative, you have 2 complex solutions. And if it is 0, you only have 1 solution, which we would call a double root. So let's do the math here. We got negative 4 squared, which is 16, minus 4 times 2 times negative 1. And I get 24 when I do that. Essentially, this is like saying 16 plus 8, because the negative times the positive times the negative is a positive. Negative 4 squared is 16. 4 times 2 is 8, so 16 plus 8. We've talked about 24 already in this video, I think. It is the same thing as root 4 times root 6, where we can take the square root of 4. Square root of 4 is a 2. So we get 4 plus or minus 2 root 6 all over 4. Now, as we're representing the answer, since all three of these parts that are not under the radical, but the three parts that are all divisible by the same thing, one way to reduce this is just to divide all of them by 2. So you get 2 plus or minus 1 root 6 over 2, which you could simplify by dropping the 1 and just have 2 plus or minus root 6 over 2. What I'm going to do as I solve this problem is I'm just going to go ahead and break it into 2 fractions. Okay, so I'll have 4 over 4 plus or minus 2 root 6 over 4. So that I can go ahead and say 4 divided by 4 is positive 1. And then the 2 and 4, the 2 cancels out. It goes into the 4 2 times. So this becomes like a 1, and that becomes like a 2. So what's left behind 1 root 6, we just write as root 6 over 2. We circle that like that. That's one way to write it. It would probably be acceptable if you had the 2 plus or minus root 6 over 2. I think that might be acceptable also, but since I can reduce this 2 with this 2 like this, I'm going to go ahead and break it apart into 2 fractions. And I think that's a more simplified answer, since I can simplify that fraction just a little bit more. Well, that is it for examples today. I do want to point out something that is not found in the example. So in question 1, we had a root 24 and ended up with a root 6 left. If this had been like root 16 or a perfect square, I would have ended up with 6 plus or minus 4 over 2. And you actually can do that math. So if you have a perfect square under if your discriminant is a perfect square, none of these happen to be that way. They were all they all had something left under the radical. But if it's a perfect square, you actually have to work out the problem all the way and get the 2 integer answers, or the 2 rational answers. You want to make sure that you work it out as far as you can. I hope that this video has been helpful and that it helps you understand better how to use the quadratic formula. I will see you in class.